welcome to this nice Thursday morning here to check out our webinar and the ins and outs of equipment qualification. So I'm Matt Schustrick, Vice President of Sales here at Paragon, and I've got with me Ross Lorberbaum. Ross is probably one of the best in the industry to talk about equipment qualification. I know it is really a passion of yours, Ross, so welcome.
Absolutely. Thank you, Matt.
Yeah, no problem. Why don't you tell everybody, how long you've been with Paragon and what fascinates you about qualification so much?
Sure. Good morning, everybody, or for all you international folks, maybe good afternoon or evening. Again, my name is Ross Lorberbaum. I'm one of two mechanical engineering managers here at Paragon. Been with the organization for roughly 10 years. I've been involved with qualification ever since I started. I think my first project here at Paragon was a harsh qualified application for spent fuel pool monitoring. And ever since then, like Matt said, it's been a huge passion of mine. It's really a passion for the organization in total. Qualification is just such an unbelievably critical topic. It speaks volumes to our nuclear safety culture. And it's really incredible if you think about it, that we have both domestic and international governing guidance accepting a standardized process for how to qualify equipment for nuclear related applications. So it's a fantastic topic. I think this is our second webinar on the subject. It certainly deserves the attention. So we're excited to be talking about it today.
Yeah. And to the note of international, we have got an overwhelming presence today from north of the border in Canada and also across overseas. So welcome to all you and thank you guys for showing up. Appreciate it. So just a couple housekeeping notes. So we got everybody on mute for the duration of the webinar, but please use the QA button or the chat feature, either one. If you have any questions like during the webinar, as we go through anything or topic comes up that maybe you want to cover a little more or maybe some clarifications, go ahead and pop it in there. And then at the end, we've got a Q&A session, so we can address everything there. Also, it's being recorded. After the webinar is concluded, y'all will get a copy of the recording to share with maybe some colleagues that couldn't make it. So pretty big agenda. So I'm going to go over just a quick introduction on Paragon, who we are and what we do, and then turn it over to Ross to really cover, everything that goes into qualification. As you can see, there's several considerations to take and several kind of topics in the realm of qualification. So, we've got a lot to cover, but some really good information for everyone. So just quickly, who's Paragon's? We're the largest non-OEM nuclear focused supplier in the US. We are now over 215 employees. 70 of those we just hired this year. So we had some tremendous growth in 2021. I know some was, I'm sure, due to COVID last year, things being put on hold. And then, we had a massive influx this year in our business. But a lot of it we can attribute to, our really company value of customer centricity. We meet our customers' needs, exceed expectations. That's really number one. We definitely have an innovative approach to everything. We get approached daily from utilities across the world, with problems they have with obsolescence or needing to upgrade systems. And so we really do take an innovative approach to all of those to give them a solution that meets their needs and exceeds their expectations. And that's also why we're really steering towards a lot of the advanced reactor sector right now and helping those folks out. So we really invest heavily in the people we have here, the people we hire, who we hire, and also, we have the technology to support our changing industry. Like I said, not just in the commercial fleet, but also in the new advanced reactors that are coming into our industry and that are going to eventually change our world. A lot of our staff as well has, extensive industry experience, whether they've worked at nuclear sites before, like yourselves, or just been in the industry. They know the industry and, how to handle anything that comes our way. So as you can see here, this is kind of our wheel of excellence or wheel of expertise, whatever you want to call it. We're here today to talk about equipment qualification, and that can also spread into really almost all the other sectors that we cover in all the other business units, whether it's in custom design with new systems, alternate sourcing, INC, repair and reverse engineering, commercial grade dedication, and then we have a data services business sector as well. So if you're interested in any of those other areas, though, you know, and want to see a webinar on them, because I think we pretty much have a webinar on every one of those. I think we're over 12 or 13 now. Please visit our YouTube channel. So just search for Paragon Energy Solutions, click on videos section, and all of our webinars that we did in the past are all posted there. This one will also be posted there once we're done. It'll go straight to our YouTube channel. So if you don't get the link, just hop over to YouTube and you'll be able to view it and download it there. So with that, Ross, I will turn it over to you, and you can probably start out by telling everybody what equipment qualification is.
Great. Thank you, Matt. Thanks for getting us kicked off there. So what better way to start discussing qualification than a definition of what qualification is? On the screen, you can see the standard definition pulled from industry guidance, but really, if you strip it down to its most basic form, equipment qualification is how the nuclear industry provides the necessary assurance that a given piece of equipment is going to meet its intended safety function, even throughout the worst case environmental parameters associated with the installed application. So it's really an incredible process. It speaks hugely to our safety culture. Again, the objective here is to provide the necessary assurance that design or age-related common cause failures are not going to keep your equipment from performing its intended function. And so how we do that, it's going to be a combination of either evaluation, testing, or analysis, not only for your normal conditions, but also for abnormal conditions, postulated design basis conditions, anything that's going to be impacting your equipment from an environmental standpoint is going to be included in a qualification program that's going to have to verify the assurance that our industry requires. So when you're talking about qualification, it's typically broken down into 3 different categories. We're going to cover each of these here in this webinar. You have your mild environment seismic only qualification, harsh environment qualification, and then EMI RFI, or electromagnetic compatibility qualification. We're going to kind of differentiate and talk about mild and harsh environment qualification first, and then we'll kind of split out into the EMC qualification in some separate slides. But to really get started going through some of these associated steps with these programs, you know, I wanted to talk a little bit about what some topics are that need to be thought of during procurement activities, and something that could help you whenever you're going to your vendor with an RFQ. We're trying to set up a program for equipment that you need for a qualified application. So, you know, just in general for this webinar, there's a lot of topics to cover. From a technical perspective, we're going to keep it pretty high level. We're really going to focus on driving lessons learned and risk mitigation techniques throughout each of these areas. So to start off, some things to think about: qualification is a completely separate activity from dedication. There is some traceability between the 2 activities, but they are separate, and it's required for you to know if your application requires mild, harsh, or EMC qualification. It's going to be critical in driving your RFQ questions and what you're asking your vendor to support. One of the first things to think about there, if you do have a qualified application, is there an existing report? Because it might be possible for your vendor to establish traceability to that previous qualification program for new scopes of supply. So before you go down the road of thinking that you have to perform a new type test, new qualification program by testing or analysis, work with your vendor, find out if it's possible to establish traceability to that original report. If not, you're going to be performing a new qualification, new analysis or testing. It's going to be required, so you'll have to work with your vendor to get that going. If harsh EQ is required, this is an extremely important topic. Matt, I know we get this question all the time. Schedule is an unknown variable and could take a significant amount of time. We're going to talk about the attributes of qualification that play into that, why that is, in some slides to follow. But especially when you're thinking about your procurement needs, it's really important to understand, and for the most of the time, your vendor's not going to be able to commit and formalize a lead time until a couple critical activities happen a little bit further on along in the process. And finally, we kind of mentioned it just a minute ago. You're going to want to be thinking about possibilities for risk mitigation and reduced negative schedule impacts. And some of these topics are going to be great for you to know on the procurement side. They're good to talk with your vendor about. Your vendor should already have a program that implements a lot of these But knowing these topics is only going to serve to improve this whole process and help you out in the end, getting the qualified equipment that you need. So let's say that you're procuring some equipment, it has qualification required. Some of the information that your vendor is going to require, it's first good to understand that the test sequence and methodology are fully based upon the licensing basis of the plant. Your vendor is going to need all of the applicable industry standards, specification, application-specific requirements. The more detail, the more information you can give, the better chance you have of setting up a program that's going to meet your requirements. If you're working with seismic only qualification, your vendor is going to need the seismic required response spectra, or RRS, all associated parameters, whether that's amplification factor, damping values, if you have multiple locations, rooms, elevations, what's applicable to your equipment, and the intended installed configuration. If you're looking at harsh qualification, you're going to need your desired qualified life, whether you're wanting to install your equipment for 40 years, 60 years. There's some risk mitigation strategies and some schedule acceleration factors we can talk about here in relation to qualified life. We'll get into that a little bit and here in a little bit. You're going to need to know all of your environmental parameters for normal, abnormal, and accident conditions. So you're thinking temperature, pressure, humidity, accident conditions, etc., along with your RRS and any installed configuration attributes. And then for EMC, you're going to need your governing guidance and specifications, requested tests, associated test levels, and the installed configuration. It's all going to be very critical to make sure that the testing your vendor performs is traceable to the application that you're shooting to envelope. And then make sure that you work with your vendor documentation review and approval requirements. If you want to approve those qualification plans, qualification reports, if you want to be involved in the process. Here at Paragon, we love supporting people coming to our facility, witnessing tests, being a part of the qualification. We certainly welcome you. It's even encouraged. The more interaction we have, the more knowledge we can gain and try and complete some successful qualification programs. So make sure you work with your vendors on those fronts. So to start off, again, we're starting with mild and harsh environment qualification. It's important to be able to differentiate between those two. These are standard definitions for those environments. It comes straight out of IEEE 323. It's widely accepted domestically, internationally. If you define your environments differently, we can certainly support that. Your vendor can support that. But in general, if you have an environment where at no time is any environmental parameter significantly elevated in respect to your normal operating conditions, you'll be working with a mild environment qualification, and you can move forward with that procurement process accordingly. On the flip side, if you have environmental parameters that exceed normal operating conditions, regardless of what parameter that is, if it's one or more, you could be working with a harsh environment qualification, and you're going to have to move forward with that qualification program accordingly. And again, you're going to be looking at things like temperature, pressure, humidity, not only total integrated dose for radiation, but also dose rate. We'll talk about why that is. And then any accident conditions associated with loss of coolant accident, high energy line breaks, all of that's going to be applicable to both of these. You're going to need to work with your vendor to be able to define what's appropriate for your application. So on this slide, we actually went ahead and broke down from a bird's eye view what typically is going to be involved with your qualification programs when you're working with your vendor. So it's broken down into mild and harsh. So starting off with mild environment qualification, there's obviously way more mild applications than there are harsh. You're looking at your vendor preparing a qualification plan, procuring test specimens and production units if you're ordering at the same time, receipt inspecting those test specimens, establishing traceability, and jumping straight into a qualification program that's going to typically include a baseline functional test, followed by your actual seismic testing, and then a post-seismic baseline functional test and report generation. If you're looking for a harsh environment qualification, it's a more intricate process. There's many more test steps. For the most part, these are the sequential test steps associated with your standard harsh qualification, especially domestically. Depending on the guidance for your application, equipment type, and if there's any synergistic effects between thermal and radiation, order of operations could change here a bit. And especially for you small modular reactor or advanced reactor folks, you might have some additional tests outside of what's standard for the nuclear operating fleet. You certainly have some elevated conditions higher than what we're used to seeing, but we're unbelievably excited to be able to tackle those qualification challenges and get those programs going for you. but the core methodology of the steps identified here are still going to apply. There's still a value for those applications. So we're going to go through each of these in future slides to define what they are. But in general, for harsh qualification, you're still going to have your vendor prepare a plan, procure material, receipt inspection, traceability, all of that's the same as mild environment. And then the following 3 bullet points play directly into the statement made previously about unknown lead times for harsh qualified components. Thermal aging is going to be the longest, typically the longest duration item in any harsh qualification program, and material analysis, heat rise testing, and thermal aging calculation are going to play a direct role in defining how long your equipment has to be aged and when you can expect your lead time to be completed for this qualification program. So those are really critical steps for you knowing when can this qualification be completed? Am I going to meet a critical install date for scheduled work, outage, whatever situation you might be in? This is going to play a critical role, and it is an unknown up front. So once those items are defined, you have your aging duration nailed down, you're going to roll into the meat of the program, starting off with always a baseline functional test, followed by your aging mechanisms. That's going to include thermal, radiation, mechanical and electrical cycling, followed by seismic testing. And then at the end of life condition, you're going to be looking at performing your accident tests, any post-accident aging, and your final baseline functional test. So a lot to cover here. It's a very intricate process, and it's going to be great to be able to highlight some lessons learned and risk mitigation techniques for each of these steps. So start off, let's assume that we're going for a mild environment qualification. I wanted to define what baseline functional testing is prior to moving forward. It's essentially performed prior to and after each step of a qualification program. The baseline functional test requirements should be included in your vendor's qualification plan. It should highlight and make it clearly identified what the testing methodology requirements are, acceptance criteria as it relates to the safety function of the item and how it's supposed to operate and maintain integrity throughout those environmental conditions. So your BFT is really going to serve a number of purposes. It verifies the test specimen meets both passive and active safety function requirements. It establishes a pre-tested condition and functionality of the test specimen, which is unbelievably critical. It's your first step prior to exposing your test specimen to any environmental parameters. And then not only that, it also impacts and documents the impact of each qualification step on the test specimen. So you can compare any baseline functional test back to the original and see what the delta is on any operational characteristic, any structural integrity or degradation characteristic. It's a way for you to determine how your program is progressing and how the environment is impacting your test specimen. So it's going to be a common theme, lessons learned and risk mitigation strategies for baseline functional testing, some things that we've come across over the years and that we implement standard practice in our program. You want to minimize test specimen setting adjustments, and you want to make sure you're simulating the intended application. And then you want to reduce any required handling and transport of the test specimen. And really, the underlying root cause of why you want to be concerned with these things is you don't want to induce a failure of your test specimen that's not representative of the installed application. The last thing you want to do is go through a qualification program and you have damaged equipment or some type of failure mechanism that happens due to handling the equipment. So work with a vendor. It's standard practice at Paragon. We evaluate test specimens. We actually fabricate custom structures and test fixtures to be able to minimize handling, moving the test specimen around through different steps of our qualification programs. So keep that in mind. It's going to be a common theme. You want to avoid failures at all costs that aren't actually applicable to the testing that you're performing. So if we're talking about mild qualification, after your initial baseline functional test, you're going to move straight into seismic testing. It's an unbelievably critical activity throughout our industry. It's going to be based upon, again, the licensing basis of your plant, associated specifications and industry guidance that controls what's going to need to be performed to meet your application requirements. And from previous slides, we kind of went through what your vendor is going to need to be able to perform seismic testing. They're certainly going to need your required response spectra. I wanted to go through some of the equipment types and what RRS is going to be applicable to your installed location. So these are generic and standard for the industry. If you're looking at equipment that's going to be mounted to the floor or a skid, you're talking motors, tanks, panels, large structures, MCC cabinets, anything that's mounted to the floor, you're going to be looking at using the plant floor RRS for that location. If you are looking at wall-mounted equipment, whether it's transmitters, panels, panel-mounted equipment, whatever it may be, typically you're going to be using the RRS on the floor above conservatively. And if you have panel, cabinet, rack-mounted equipment, this is where you actually get some options, and there's some great lessons learned and potential for you to be able to reduce lead time and cost. If you have something that's mounted in a large structure that's going to have in-panel response and amplification, you can either shake it in that structure to the floor RRS. You can actually shake it to the floor RRS outside of the structure if you have a known or prescribed amplification factor, or if you have the in-panel data for where it's going to be installed within that panel or enclosure, you can actually shake it to in-panel spectra on a rigid fixture to avoid having to have the entire structure and simulating the overall configuration of the intended application. So we'll talk about that a bit more. If you have pipe or duct mounted equipment, anything that's line mounted, whether it be valves, actuators, etc., you're going to be performing brim testing typically per IEEE 382 and associated levels conservatively. So to talk about seismic testing activities, there's a number of different buckets and testing types that you might have required for your application. First one's going to be a resonance search. It can be very valuable to know resonant frequency of your test specimen or equipment, especially if it's of a larger structure, anything constructed out of sheet metal, anything that might be susceptible to lower frequency resonance phenomena. So one area where this might be very helpful is it's common throughout the industry whenever you're shaking thing on a table to not envelope acceleration levels in the lower frequency range. It's due to equipment table limitations and just the inherent nature of seismic testing. There's actually industry approved write-off for that occurrence. If you have no resonant frequencies of your test specimen below 5 hertz, you actually don't have to envelope acceleration levels but below 3.5 hertz. It's accepted by IEEE here domestically and also an international standard. So if you have a large structure, anything that might be susceptible to those resonances in the low frequency, that can help you and that can help support the justification to be able to qualify that equipment successfully. If you have vibration aging or any vibration induced failure mechanisms, you're going to want to simulate vibration as part of your seismic program. It's an aging mechanism prior to moving on to the remainder of your testing. And then if you have any floor, wall, panel mounted equipment, you're going to be performing multi-frequency testing for both OBE and SSE conditions, DBE if you're in Canada. And I have the definitions of OBE and SSE down below. If you actually read through those definitions, you can really see how critical of a test this is to maintaining safety. So they're just unbelievably important. And then again, if you have anything line mounted, you're going to be performing rim testing for both OBE and SSE conditions appropriately. I have just a standard multi-frequency required response spectra up here, just so you can take a look at it and see what these typically look like. This one comes straight from C3798. You have your peak acceleration levels between 4 and 16 hertz and your ZPA 33 hertz and beyond. X-axis is going to be your frequency with your Y-axis acceleration. This is what your vendor is going to have to envelope to make sure that the equipment functions for your intended application. And they're going to spit out a report that includes data, kind of like the image below, that shows that their test lab has enveloped that requirement, including any margins required per your industry guidance. So you can see down below from 1 to 100 hertz that the full spectrum was enveloped. You have your time history. That's the kind of information that you can be expecting from your vendor, and that's what you need to be able to qualify your item successfully. So if we switch over to the next slide, I've listed here some information on tables that we have here at Paragon. We have 4 tables that we utilize to meet industry requirements. We have 2 biaxial, 2 triaxial, all different sizes, different capacities, different peak acceleration levels. We utilize these depending upon what the equipment type is and the application requirements to be able to meet your needs. What I really wanted to drive off of this slide, though, is the lessons learned and risk mitigation strategies for seismic qualification. It's going to be of extreme value, especially if you can work through these, ask questions, work with your vendor to see if they're implementing these in their program. It's always best practice to evaluate equipment for seismic durability prior to selection and testing, especially if you have anything large structure constructed out of sheet metal, anything that could use additional structural support. If you need strain reliefs, if you need to be able to mount and support cable or piping in a different manner, it's always best practice to analyze that up front to avoid a failure that's going to impact cost and schedule for you down the road. So work with your vendor, see if they're doing those things, do that up front prior to testing, which goes straight into the second bullet. If there are modifications that you determine are required, make sure you do it up front, whether you're adding channel, gussets, additional welds, more structural integrity, whatever you may be adding to your test setup to ensure that you have the best chance of a successful test. It's always of value to make sure that your vendor is doing that up front. And this is a big one. It kind of goes back to what we were talking about for in-panel mounted items. Include additional response accelerometers for in-panel response for panels and enclosures. So what this is going to do for you is, if you are qualifying an MCC section, you have the whole section, everything mounted inside, buckets filled, and you're qualifying that in total. If down the road you need a replacement item, there's an obsolescence issue, you're doing an upgrade, if you have that in-panel data, you can actually shake on a component level on a rigid fixture to that in-panel data to avoid the cost and lead time associated with getting that large structure and performing that whole setup from the original qualification. So work with your vendor, make sure they have that accelerometer placed, get that in-panel data, because it's only going to serve you in the future and is going to help your future procurement activities for those applications. Last suggestion here is a risk mitigation technique. Use, when you can, application-specific required response spectra. A lot of times we tend to default to using generic conservative levels that apply to a vast number of different locations and elevations in the plant. But if it's really a critical program, you need to avoid failures. It's been a long program and you've gone through, especially in harsh qualification, all the aging mechanisms. It's going to be best practice to use specific levels associated with your actual application, so you're not over testing. You don't have a failure that doesn't actually need to occur and isn't representative of the actual seismic levels for where you're installing the equipment. So always going to be great to make sure that that happens. And so mild environment qualification, after seismic testing, you're going to move straight into your post-baseline functional test. It's going to be the same as your pre-seismic baseline functional test. And that's going to give you the means to be able to justify whether or not that equipment is acceptable for those seismic conditions. So you'll get a report detailing what the process was, the results, all the information and data required for traceability, and that would close out your mild environment qualification. If you have harsh environment qualification, seismic wouldn't have happened yet. You're going to start off with all your aging mechanisms prior to moving into seismic and accident testing. The whole point there is you want your test specimen to be at an end of life, worst case conservative condition. So if you're talking harsh qualification, I first wanted to start off and talk about thermal aging. It's an unbelievably critical step just from the schedule perspective, because this is what's driving the unknown lead time from your vendor. In essence, accelerated thermal aging is used to simulate the end of life condition. So if you are shooting for a 40-year qualified life, your vendor is essentially going to run a methodology that we're going to talk about here to be able to put your test specimen in an oven at an elevated temperature, age it for a certain duration to where whenever it comes out of the oven, it's in the same condition as it would be 40 years down the road if it was installed in your plant. So you're getting end of life condition. It can be a long process. It's the largest determinant in your schedule. And it's all based upon typically the Arrhenius methodology as accepted by EPRI 1558 and various other industry literature. But the steps that are going to play a huge role in this is your vendor is going to have to procure a destructive test specimen for what you're trying to qualify. They're going to take it apart fully. They're going to test every single non-metallic material in the construction of that equipment through the use of IR spectroscopy. Here at Paragon, we actually have an IR lab that we utilize. We perform that in-house. If you're working with somebody else that has to send that out, it might be performed at a third-party facility. But you're going to have to figure out what all those non-metallics are. You're going to have to determine appropriate activation energies with the appropriate basis. And then you're going to perform heat rise testing of your equipment to know what the heat rise due to energization is. All of those parameters go straight into this Arrhenius calculation, and that's going to define how long your equipment has to be in the oven. So the smallest changes here play a big difference. Your vendor is going to have to run through this whole practice to be able to give you the lead time. And this doesn't happen until you actually get the equipment and perform these tests. So if we're talking about risk mitigation and lessons learned for thermal aging, if we go to the next slide here, You're going to be looking at knowing that thermal aging durations vary widely for different equipment types and different installed applications. We've had programs last anywhere from a couple weeks all the way to a few years. It can really be a huge delta depending on what the equipment type is. Best practice is always to run multiple test specimens through thermal aging. It's standard practice at Paragon. You do not want to commit to a long duration qualification program with no backup test specimens to be able to troubleshoot and provide justification for anomalous behavior. It's very, very critical to have multiple test specimens as a safety net and ensure that you're not going to have a major schedule slip due to a failed specimen and no backup. You always want to reduce unnecessary conservatism and aging duration by pairing activation energies with localized heat rise values. This is something that we do at Paragon. It's something that you should be asking your vendor about. You don't want to take the highest temperature rise of your entire equipment and apply it to every single non-metallic material in every case, especially if you have a larger test specimen. You want to take the time. Sorry, the slide's on the timer. You want to take the time to pair heat rises in multiple locations, not just your hotspot locations. That way you're getting a true representation of how long your equipment needs to be in the oven so you can avoid those failures due to extra conservatism that's not required. So that's an intricate process, and it's something that you should certainly ask your vendor about just because it's of huge benefit in ensuring the greatest level of success for these programs. Mitigating risk of failure due to elevated oven temperature can be handled with parallel aging programs. So what we're getting at here is typically you age things at a temperature no higher than the maximum continuous use temperature of the worst case material in your test specimen. Although this process is always a balance of risk and schedule. So if you have a critical schedule need, going in the oven at a higher temperature shortens the duration of your aging program. So if you do want to try and get things done on an expedited basis, you can put one test specimen or multiple test specimens in an oven at a higher temperature, have backup test specimens at a lower temperature running parallel path. That way, if the higher temperature does pass, great, you're meeting schedule needs. It was accelerated faster than the lower temperature, and we can really meet some of your critical install dates. If it does end up having a failure due to that oven temperature, which is completely separate from the installed application, then you still have those backup test specimens running at the lower temperature so you don't lose that time. So it's a really great option to be able to try and get a faster qualified piece of equipment, but not binding yourself to where you're going to have to restart if you end up having a failure. And then if there is potential to replace age-sensitive materials with ceramic or metallic components, it's always extremely beneficial to look at that up front, especially with very age-susceptible and thermal-susceptible materials. If you can switch it out with something that's more radiation hardened, and especially if it's ceramic or metallic, it's only going to serve to give you a better chance of having a successful qualification. And one thing I wanted to talk about that could also benefit your procurement needs is if you're in a bind for schedule, you can still talk about parallel aging programs for a lesser qualified life. Not only can you have different components at different temperatures to try and expedite that process, but you can also shoot for a lesser life, meet your install date, and have us follow up with a qualification program to provide you an extension later on. So what I mean by that is if you have a 40-year qualified life that is really what you're desiring, but you have an install date, you find out it's going to take 6 months to age it for a 40-year qualified life. If you want to get a 5-year qualified piece of equipment so you can meet your install date, we can run 2 separate programs at the same time, get you the lesser qualified life, and then we'll provide a report revision later on that's going to extend that same equipment to the longer life, given it's an acceptable program. So it's something there that's pretty unique. It can really help you out in certain situations where your procurement activities didn't happen early on enough to be able to allow you that full 40-year duration or whatever you might be shooting for. So whenever you're going through the RFQ process, it's really something great to bring up, especially if you're in a schedule bind. So thermal aging is complete. You're continuing on through your aging program. The next step is typically going to be radiation. Radiation evaluation or testing shows that a given test specimen can maintain the required safety function after being exposed to the dose rate and total integrated dose for the application. There's two different avenues that you can take here. If radiation is your only elevated environmental parameter, there's something that you can do that can save you cost and lead time and avoid a testing program. And you can instead determine the non-metallic materials of construction, determine if there's any electronics, and you can find out radiation thresholds for that equipment while you can avoid actually testing it. So there's a number of industry documents, EPRI 2129. There's many throughout the industry that have functional thresholds. I have some listed here for electronics and non-metallic materials. So if you have a piece of equipment, radiation is the only elevated environmental parameter, and it doesn't contain Teflon, you can actually accept that equipment for anything under 1E5 rads gamma while avoiding all that scheduling costs associated with the qualification program. So talk to your vendor if you have that type of environment and save yourself a headache and all that time associated with actually testing for these conditions. If radiation isn't your only elevated parameter, you're in a harsh qualification program, it's going to be testing. Testing is going to be required. Likely when you're working with your vendor, it's going to be through one of their approved third-party test facilities, and you're going to be shooting to envelope the maximum plant dose rate and total integrated dose for the desired life. So you're going to be having to look at both of those attributes, including any margin, dosimetry error, anything that's applicable to the third-party facility that you're using. And it's going to envelope both normal and accident conditions. So radiation is a critical step. There's a lot to know here. There's a lot of information out there in the industry. So work with a vendor that's very familiar with performing this testing. If we click over to the next slide here, I think we have some lessons learned in risk mitigation. Again, our common theme throughout this whole presentation, but dose rate and total integrated dose both introduce a potential failure mechanism for your equipment, especially for electronics and dose rate effects. It's going to be important to understand that and test appropriately. For programs with long aging or expensive equipment, monitoring equipment functionality during radiation could be extremely beneficial. This is something we actually discuss with our clients all the time. It comes up in the RFQ process all the time. If you have equipment and you're going through a harsh qualification program, if you send out your test specimen out to a radiation facility that's unmonitored, you go for your TID, you get it back, you're performing post-radiation baseline functional testing, and your equipment's not working or no longer functioning appropriately in accordance with your acceptance criteria, you don't know where that radiation threshold was to be able to follow up with a backup test specimen to that threshold. If you actually work with somebody that can monitor the equipment throughout the radiation program and monitor its performance in relation to acceptance criteria and it fails, you can correlate that to a radiation dose that it failed at, which allows you to be able to take your backup test specimen, age it right up to that threshold, and continue on with your program without a major schedule hit. So that could be extremely beneficial, especially for electronic equipment. A lot of times it's needed to be able to understand how it operates during the irradiation process. So work with your vendor there and understand the impact of unmonitored versus monitored monitoring, so or irradiation. If you have a vendor, it's always best to have multiple approved radiation labs. They all have different capabilities as far as size of the test specimen they can accommodate, dose rate and total integrated dose capabilities, monitoring capabilities. Some labs are 8 hours versus 24 hours, which could have a long impact on the lead time to be able to get radiation done. So it's always, again, a balance between needs for the equipment type, schedule, risk of failure. You always want to be able to balance that and work with somebody that understands those intricacies. Lastly, we talked about it a bit at the beginning. Handling always has the potential to introduce a failure that you definitely want to avoid. You don't want to have a failure due to handling. So make sure that you're working with somebody that has packaging and has a reduction of handling process. Make sure it's getting on dedicated trucks. If it's leaving the facility, make sure that they're crating it, packaging it to minimize handling and any impact of that shipping process, especially in the age condition. You don't want to induce, especially a structural failure due to moving and transport of the equipment. So that's going to be important. Thermal aging and radiation is done. You have, from an aging perspective, you need to next think about mechanical and electrical cycling. It's a critical step for applicable equipment. It's going to be required that you cycle the equipment to envelope the number of cycles that are expected in the installed application. If you don't know how many cycles that's going to be, there is industry guidance to help you out on that process. I think IEEE 649 has suggested cycling requirements for various equipment types. But again, you don't want to over-test. You don't want to exceed what's required. You want to know the number of cycles required for when it's going to be installed. You're going to want to define what a cycle is. Is it cycling a contact from an original position, close or opening and back to the original? Is it half of that process? Is it rotary or linear motion of an actuator? You want to make sure that you and your vendor are on the same page as to what's required for cycling, how they define a cycle. And then you're going to want to establish the cycle rate for your test, which will define the lead time associated with that portion of the program. And then you'll always want to simulate any input parameters and configuration that's going to be in the plant, whether that's voltage, amperage, whatever the conservative configuration is going to be. You're going to want to be able to implement that during your program to be able to simulate this appropriately. So not a lot to talk about here on mechanical electrical cycling. It's fairly straightforward. It's typically not a long process. And your vendor is able to automate that at times to be able to knock that out and get that done for you. So this is the part of the program for harsh qualification where seismic testing is going to fall. It's after your equipment's been aged, it's in its most degraded state, it's at end of life condition. You're going to put it on the seismic table and run through the same seismic criteria and methodology as we talked about for mild environment application. There's no difference there, followed by a baseline functional test. And then you're going to move into your final step of the qualification program, which is going to be accident testing. This is probably the most critical step. Again, your test specimen is in its worst case condition, and you're going to have to expose it to the worst case environmental parameters during accident conditions in the plant or facility, whether that's loss of coolant accidents, small or large, whether there's inventory remaining in RCS, whether there's superheat, main steam line break, other energy line breaks. It's important to understand what accident conditions are going to impact your test specimen, because your vendor is going to have to envelope all of those conditions appropriately while avoiding overshoot and getting an accurate representation of what this thing's going to be exposed to in the application. So again, you're going to need to transmit temperatures, pressure, humidity, chemical spray requirement, all in relation to time, because your vendor is going to have to put together a profile to be able to envelope those. And they're going to have to put it in a LOCA chamber capable of enveloping those conditions. So here at Paragon, I know that we have a accident test fixture that we utilize that's capable of enveloping any industry requirements from the nuclear operating fleet, AP1000 requirements. We can get superheat conditions up to 450 degrees F plus, pressure levels to envelope any condition we've seen thus far. We have 2 chemical spray tanks to be able to separate chemical spray composition requirements for different portions of the accident test. And we also have, I think, roughly 12 accident chambers that we utilize for different equipment types. And we actually custom fabricate new ones depending if the equipment is going to fit or be suitable for one of the chambers that we have currently built. So it's going to be really important that you work with your vendor, make sure that they're going to envelope your conditions appropriately, avoiding any overshoot where possible. They have a chamber capable of exposing your test specimen to exactly what's required for the accident conditions. And parallel path, they're going to have to monitor operational or integrity of the test specimen throughout this process. So it's quite an extensive test setup. It's a very detailed test. So make sure you're working with a vendor that understands that appropriately. After you finish accident testing, you're going to be moving on to any post-accident aging baseline functional test. And hopefully at that point, you'll be able to write a report that details the successful qualification of your program so that you can get the equipment that you need. That really wraps up environmental qualification testing from a mild and harsh perspective. I know there were a lot of topics to cover there. Hopefully you can retain some of these lessons learned and risk mitigation strategies, but it's good to understand what's going to be happening with your vendor just so you can work with them. Ask those questions that are going to be critical to minimizing your risk and to making sure that you get your equipment. Before we move on, I wanted to talk a bit about EMC and software V&V. EMC is a qualification activity. It can be performed on a test specimen that did not go through the environmental portion of the program. It can be handled parallel path. It might be related to equipment that doesn't need harsh qualification at all. It's its own EMC. It's its own qualification step. So You're going to need to give your vendor all of the regulatory guidance and testing requirements, what's required for the application, the associated levels. You're going to need to work with a vendor that has the capability to test those, whether it's in-house or with an approved vendor. I know that we have an EMC test lab in-house that's NRC Red Guide 1.180 compliant, also TR 102.323 and associated MIL standards. We can accommodate IEC testing for emissions and susceptibility. We have a really strong engineering program in the EMC department that can meet your needs. It's good to know that it's common practice that EMC qualified items are going to need modifications to be able to meet your application requirements. There's a lot of different things to look at to make sure that we're meeting your application as far as configuration and test setup and providing traceability to how we test the items to meet your application to minimize risk. If you have any questions related to EMC, we have Jeff Stubblefield on the line. That's our subject matter expert in EMC qualification. So work with your vendor, get your EMC knocked out, get the qualified equipment you need. And if you need help on that, we're certainly here to support you. The last topic here that I wanted to discuss is software verification and validation. Again, Jeff is our subject matter expert, but we really just wanted to mention this because it's best practice to verify your V&V upfront prior to committing to all the costs and schedule and lead time associated with the qualification program, just because you want to make sure that your manufacturer of the equipment that you're supplying has all of the processes, procedures, and controls in place to be able to successfully dedicate that digital equipment, associated software. You want to make sure that you can go through that process and verify that upfront prior to going down this long road of qualification. So V&V activities are extensive. I think a lot of facilities are back to allowing visitors. A lot are supporting remote surveys in this regard. So make sure that you work with your manufacturers and vendors, make sure that V&V can be done, make sure you're on a good track to be able to get that done successfully so that you can move on to qualification after that appropriately. So to kind of wrap things up, we wanted to go over some EQ experience. I think it's important to note that Paragon has supplied over 12,000 projects that require equipment qualification to various clientele throughout the world. We have a number of EQ experts that are very knowledgeable about all the standards associated with qualification. It's a huge passion within our organization. We've been involved with EPRI, the NRC, on helping to write industry guidance. Our procedures and techniques maintain schedule and avoid costly rework. Again, risk mitigation is the name of the game. I can't overemphasize that enough. The more that you deal with qualification and work with it on a regular basis, risk mitigation is so unbelievably important. Our EQ reports are all inclusive and remain available. Your documentation has to have a high level of integrity, has to be clear, concise, include all the information that's required, not only to understand what happened on the program, but also to be able to provide all the information you need for traceability for future scopes of supply. So we place an unbelievably high priority on that. It's going to be important. You want to make sure that your documentation's up to industry standards. And then we also provide nuclear equipment qualification technical support. If you're working with qualification activities, definitely reach out to us. Our expertise is here to help you, and we're certainly look forward to working with everybody on a qualification front. With that said, Matt, are you going to go over our peaks capabilities here a bit?
Yeah. Well, thanks. That was great. I think everybody should be experts now.
Hopefully.
Did a great job, man. Looks like we do have a few questions. So before we get into those, I just wanted to, let everybody know, as Ross said just now, we've got 12,000 plus qualifications under our belt. And so those are all searchable in our Peaks database. So if you all aren't familiar with our Peaks database, it houses over, it says 9 million here. We're up to 12 now, 12 million inventory records from the nuclear industry. So those are, items that could be available if you guys are in a bind at some point. But it also houses all of Paragon's IP on anything we've reverse engineered, repaired, dedicated, or in this case, qualified. So as you can see, if you're looking for, say, this breaker here as an example, it'll show you there at the bottom if that's something that we have indeed qualified before for somebody. So, we're not kind of reinventing the wheel. So if you're looking to have something qualified, you can definitely use our peak system, which you can access on our website, paragones.com. There's a search bar at the top. Just type in your partner, any part you're looking for, even if it's not something that's qualified. If you're just looking for a part in general, we can help get that for you. But you just type your part number in, request a quote. If it's on the flip side, if it's something that maybe we haven't done, but you still need it qualified, you can still do the same thing. Search your part number. It may not show up, but that says, don't stop there. You can still request a quote and, contact us regarding what you're looking for. You can check the box, whether it's you just need something dedicated, qualified, reverse engineered, or repaired. And that shoots a message right to us. And, our inside sales team will get back to you right away. So, check it out. It's really simple to use, and there's a lot of really good information there. So, Ross, you can go ahead and cover the takeaways, and then we'll kick it over to questions real quick.
Yeah, definitely. So just to wrap it up, some of the key points that we went over and some of the main takeaways we wanted you to be able to drive from this presentation is that obviously risk mitigation is a critical aspect of qualification. You've got to have those safety nets. You've got to take those measures. Qualification is an intricate process, and there's many different options to meet your needs. So work with your vendor and determine what's going to be best that give you the best chance of receiving the qualified equipment that you need. Schedules an unknown with EQ, allow sufficient time to meet your need by date. If you do get in a pickle, if you're in a situation where you need to meet a critical date, you don't have the time there, we do have the potential to work with you on that. So reach out, see what's going to be an option, see if we can meet that date and get you the equipment you need. And then work with your vendor to develop an EQ process that works for you. So depending on what your application is, what your equipment type is, what your schedule needs, cost needs, we're here to support you. So let's keep nuclear strong. And we
the biggest thing is start early and identification. Get it to your vendor, and it should be a very strong dialogue back and forth. To just keep the dialogue going, because a lot of delays can be, in technical questions. And so, having a lot of back and forth and being very interactive and proactive and getting the process starting early will be essential in meeting any of your schedule needs. I mean, that's the biggest thing we see where, things get delayed or, everybody has different priorities at the stations, but it's very instrumental to identify anything that needs to be qualified up front and early to meet those schedules. Because as Ross said, especially in the thermal aging section, when you get into accelerated aging, because you're kind of have your back to the wall on meeting a need date. If you have a failure at that point, you have to restart over unless you run parallel paths as well. So that's why we wanted to make sure we covered some risk mitigation techniques, but also we can get things started early. It'll be a win-win for everyone.
Exactly.
All right, so we'll move on to questions. I did see one in the Q&A. Let's see, did somebody answer it? Ross answered it. Oh, I think that's Ross number 2 answered it. Yeah. So just for everybody's sake, which increase of ambient temperature do you consider to define as a harsh environment? So, Jeff, it looks like you answered this. Typically, electromagnetic equipment have continuous use temperatures up to 50 degrees Celsius. So anything above that would be considered harsh, correct?
Typically, depending on the equipment ratings, it largely is about equipment ratings, continuous use temperature of the non-metallics. But yeah, we would consider 50 degrees C approximately what you would consider. Anything above that ambient temperature wise, it would more than likely be considered a harsh environment. And we also have to factor in heat rise due to in-cabinet in-cabinet temperature rise due to the energization of equipment. So that can go up upwards of 10 degrees Celsius on top of that in ambient environment. So that's also included in our harsh equipment qualification aging processes. We include that temperature rise.
Got it.
Yep.
Good. Thank you. I think we got another one for you, Jeff. Have you ever encountered a question of bit flip susceptibility?
I have not personally.
Got it.
Yeah.
Okay, let's see. Okay, so just two in the chat were you just naming what the acronyms were as far as LOCA, HELB, and RIM. Let's see if we have any more.
So back to that question on bit flip. We're talking about like a piece of digital equipment or a memory error. So
that would be my guess, but
yeah. And to kind of answer that, not specifically answering it, but typically digital equipment are not contained in a harsh environment due to, of course, the high radiation requirement. Ross struck on the NMOS, CMOS, and MOSFET equipment on one of the slides. So industry research has shown that they actually have this bit flipping attacks or issues with radiation at a level that's about 1E3 gamma. Some a little bit higher in some of the studies, but just digital equipment does not like radiation. And we've seen a lot of equipment be destroyed by the high radiation. So that is a very good topic. We like to see more analog equipment placed in harsh environment. That's what we see across the industry.
Yeah, something good to note there also is if, especially for some of these advanced reactor environments, if you do have digital equipment that's going to be in elevated conditions, especially radiation, that's where you're going to have to start looking for the potential to have remote electronics, shielding capabilities. Your vendor certainly has those capabilities to be able to come up with those solutions. So I know we've had a number of transmitters in the past that we had to incorporate tungsten shielding on, look into different methodologies to be able to attenuate that radiation level. So even if you do have an application where some of these digital components are going to be in elevated radiation environments, it's important to note that there are techniques to be able to give you the best chance of finding the best equipment that can actually survive that environment. So best practice is obviously always not to have that equipment in those areas, but if your application dictates it, there are those options to be able to gain a high level of success and get you a piece of qualified equipment. So
yeah, good. All right. Let's see. I think that's it. Does anybody else have anything else?
There was one question that I just answered. So to answer the question, yeah, 1E5 rads gamma is typically your threshold for most equipment that's in a harsh environment that does not contain Teflon. Yeah, so the rads to grays conversion, I believe, is what one rad is 100 grays or vice versa.
that's right.
So it's just a factor of two orders of magnitude. So whatever that is, that conversion.
Thanks, Jeff.
Yep.
All right. Well, I don't see anything else. So please feel free to reach out to us either on our website, paragones.com, info@paragones.com is a good email to address any technical questions, sales questions, anything you need. Phone numbers there as well. So you can get a hold of us in any way possible. So with that, I'll end this, and y'all should be getting a copy of this recording at some point once it wraps up. All right. Well, thanks Ross. Thanks, Jeff. And thank you everybody that joined today. Have a great day.
Bye.
Thank y'all.